As discussed in the previous video, all software process models can accommodate the generic framework activities. But, the process models apply different emphasis on these activities, and define a process flow that invokes each framework activity in a different manner. In this video, we will learn about three process models, namely, Waterfall model, V model, and Rapid Application Development model. The Waterfall model, also called as the Classic Life Cycle model, suggests a systematic and sequential approach to software development. It begins with customer specification of requirements, and progresses through planning, modeling, construction, and deployment, closing in ongoing support for the delivered software. As the diagrammatic representation of this model resembles a cascade of waterfalls, therefore, it's called as Waterfall model. The Waterfall model is the oldest paradigm for software engineering. This model is applied for the situation when the requirements for a problem are well understood. This model is also applicable for well-defined enhancements or adaptations required to be made to an existing system. For example, an adaptation to accounting software that has been mandated because of changes to government regulations is a well-defined statement of purpose. However, there are certain problems associated with application of Waterfall model for software development. The workflow from communication through deployment is a reasonably linear fashion. This is why Waterfall model is often termed as linear model. Real projects rarely follow the sequential flow which the model proposes. Although the linear model can accommodate iteration, it does so indirectly. In addition to this, it is often difficult and unrealistic for the customer to state all the project requirements explicitly. The Waterfall model requires this, and has difficulty in accommodating any requirement changes during the software development, and, with the natural uncertainty that exists obviously at the beginning of many projects. Other important point to note is that the working version of the programs will not be available to the customer until late in the project schedule. This indicates that, if any major mistakes remain undetected until the working program is reviewed, the situation can become disastrous. In an analysis of real projects, Braddock found that the linear nature of the classic life cycle leads to blocking states, in which some project team members must wait for other members of the team to complete the dependent tasks. For today's fast-paced software work, and never-ending stream of changes to features, functions, and information content, the Waterfall model is often inappropriate to its application for actual software development. Another software process model is the V model, which is a variation in the representation of the Waterfall model. The V model clearly depicts the relationship of quality assurance actions to the actions associated with communication, modeling, and early construction activities. As a software team moves down the left side of the V, basic problem requirements are refined into progressively more detailed and technical representations of the problem and its solution. Once the code has been generated, the team moves up the right side of the V, essentially performing a series of tests and quality assurance actions, which validate each of the models. Specifically, there is no fundamental difference between the classic life cycle and the V model. Actually, the V model provides a way of visualizing how verification and validation actions are applied to earlier software engineering work. Let's discuss an example of software project development process using these pictures. This picture describes how the customer explained his requirements about the software. And this is what the project leader understood after discussion with the customer. When the project leader conversed the requirements understood by him, this is what the developers programmed for the software. This is how the business consultants described it. As the outcome of this project, these operations were installed on customer's site. And, this way, the customer was billed. But, actually the customer needed this. You can easily observe that the conversation from one point to the other was completely different. Especially, what the customer explained about his or her requirements, and what he or she really needed. Therefore, this whole scenario indicates that user involvement during the software development is very essential. User participation is one of the key features of RAD model, that is, Rapid Application Development Model. In the RAD model, a rapid prototype of the software is built. The prototype can be a usable program, but is not suitable as the final software product. A prototype gives a model look and feel about the project to the customer. This prototype is given to the customer for evaluation. The customer gives a feedback and suggestions after evaluating the prototype. Based on the feedback given by the customer, the prototype is refined until it is approved by the customer. Once the prototype is finalized, the project requirements are well understood, and the project scope is clearly defined. Project requirements are divided into different parts or increments. As RAD is an incremental process model, it emphasizes on short development cycle, specifically, between 60 to 90 days. The other SDLC phases, such as modeling and construction, are conducted in parallel by different RAD teams to complete all increments of the project. There are certain limitations of RAD model. The RAD model is not suitable for the projects in which user involvement is minimal. Moreover, to reduce the development time, reusable components are required for the project. Also, highly specialized and skilled developers are required in the teams in order to apply the RAD model for software development. In addition, we need appropriate number of human resources to form the RAD teams. So, we discussed 3 software process models in this session, including the Waterfall model, V model, and the Rapid Application Development model. That's all for this session, and in the coming sessions, we will discuss some more software process models. Thank you.